All right, 6.3, medians and altitudes of triangles. If you look at the word median, you might think about what word it sounds like. Also, you might think about when you're driving down the road, you might think about the median on the highway. The median is the middle, okay? If you think about median, middle, they kind of sound alike, and the median of the road is, in the middle of the road. So the median is a segment from a vertex to the midpoint of the opposite side. Now, I'm going to freehand this. Technically, you should measure, all right? So technically, I should measure this and then divide by 2 and find exactly where the midpoint is. I'm just going to estimate on here, all right? But I'm going to draw the median from the vertex to the midpoint, all right? And then I'm going to estimate the midpoint here, and I'm going to draw from this vertex to that midpoint. And it's a little bit off, of course, because why not? And then I'm going to draw from this vertex, and of course it's off again, to the middle, which I gotta get this adjusted. Approximately there. Okay, so those are all medians. They go from a corner or a vertex to the middle of the opposite side. Then we have an altitude. That is a segment from the vertex perpendicular to the opposite side. So in this case, we're drawing straight, you could say straight down, but it's going to be coming in at a 90-degree angle. Okay? And then this one, like so, at a 90-degree angle. And then this one, again, I'm just rough sketching this, like that. Okay, so it comes in at a 90-degree angle. So those are all the altitudes. So median goes to the middle, and altitude is perpendicular. The centroid theorem, okay? The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. We'll get into the actual practical application of it, okay? But the centroid, the medians meet at point P. So if we look back here, I was roughing it, but you can tell they meet right there, okay? So the medians meet at point P. Now, if you look at this, it says AP is 2/3 of the entire segment. BP is 2/3 of this entire segment. And CP is 2/3 of this entire segment. All right? So what happens is it splits it up into 2/3 and 1/3. All right? So if you think about, let's say that CD was 12. Well, 1/3 of that is 4. So that means DP would be 4. And 2/3 would be 8. So CP would be 8. 8 plus 4 is 12. Okay? So it's very simple. I always go with the smaller one first. I do the 1/3 because it's easier math. And then subtract. Okay? So you just take 1/3 of the number and you're there. So just for practice, if AE was 15, okay, this whole line here, AE, then AP, I'm sorry, my bad, EP, the shorter segment, would be 1/3 of that. And then just subtract and get 10. So AP, not AB, would be 10. All right. Now, In the coordinate plane, the formula for the centroid is kind of like the midpoint. If you remember the midpoint, we added x and divided by 2. Well, now we're adding all the x's and dividing by 3. And we're adding all the y's and dividing by 3. So same concept as the midpoint. We're just going to a third line because it's a triangle. Okay, in RST, point Q is the centroid. SQ is 8. Find QW and SW. Now, I kind of actually did this right here, okay, just randomly. But if you notice something, look at the relationship between these two and these two. The smaller segment is half the larger segment. So if this is 8, then we know this is 4, and then the overall is 12. All right, find the coordinates of the centroid RST with vertices 2, 1. And we don't really actually need to graph this, but we will. So 2, 1 is right here. 5, 8, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So that's RST. And then 8, 6, 7, 8, 1, 2, 3. That's T. So here's my triangle. Okay. Now on a graph, you wouldn't measure, but you would technically find the midpoint here. If we were graphing it, we'd find the midpoint there. We would find the midpoint there and find the midpoint there. And that would be x plus x divided by 2, y plus y divided by 2. And we would do that 3 times. But here we're just trying to find the centroid. So that means we're going to take x plus x plus x and divide by 3. And we're going to take y plus y plus y and divide by 3. So 5 plus 2 is 7, plus 8 is 15 over 3. 8 plus 1 is 9, plus 3 is 12 over 3. And that gives us 5, 4. So if we go to 1, 2, 3, 4, 5, 1, 2, 3, 4, there is the centroid. So if I graphed, a line connecting those 2 points, I would get the intersection like so. All right? All right, there are 3 paths through a triangular park. Each path goes from the midpoint of one edge to the opposite corner. The paths meet at point P. Point P is the centroid. Oh, wow. That doesn't work. Centroid. So find PS. Okay, that's a short segment. I guess I should use a different color. That's a short segment. If SC is 2,100 feet. Well, remember, the short segment is 1/3 of 2,100. So basically it's 2,100 divided by 3. So 3 goes into 21 7 times, so 700 feet. It says find TC. So we're trying to find TC and BC if BT is 1,000 feet. Well, let's move this actually. So we know that BT is 1,000 feet. Well, remember, T is the midpoint. So if this is 1,000 feet, this is 1,000 feet. So TC is 1,000 feet, which makes the entire length BC 2,000 feet. All right, find PA and TA if PT is 800 feet. So we know this right here, the small segment is 800 feet. And remember the special circumstance, the relationship. The short segment is half the big segment. So if this is 800, then this is 1,600. which means TA, the whole thing, is 2400. All right, for your exit ticket, just draw a right scaling triangle and then sketch the three medians. Just do your best.